Hello students, welcome to Inside Physics channel. Today we will discuss some topics in fluid dynamics, how to calculate the pressure difference in a fluid. First we will see how the pressure variation will be in fluid dynamics. Okay, see here the pressure difference between 2 points inside a fluid. Pressure difference between 2 points inside a fluid. See, if what is a fluid actually? A material that flows is called a fluid, and liquids and gases have the property of flowing. Now, to calculate this pressure difference, we will take a beaker of fluid. Okay. So we will calculate the pressure difference between 2 points inside this beaker placed vertically one above the other. Suppose these are the 2 points P, Q. Now we will calculate the pressure difference between these 2 points. For that, we will take an imaginary cylinder. We will take an imaginary cylinder P on the upper surface of the cylinder, Q on the lower surface of the cylinder. Why we have taken this imaginary cylinder means if we want to calculate the pressure, we cannot calculate with a single point. We need to consider some area. So this upper surface is having area A, and the lower surface is also having the area same. Upper and lower surfaces having area of cross section A. Now we will see how the pressure difference between these 2 points. We are considering a fluid which is static, that is not moving. So here first of all we will calculate the force acting on the upper surface of the imaginary cylinder. Force acting on the upper surface of the imaginary cylinder. This is, we take it as F1 is equal to P1A. P1 is pressure acting on the surface, A is area of cross section. We know that force is equal to P into pressure into area. Now here, see this force is acting vertically downwards, and some pressure P2 will be acting in this direction, vertically upwards. So if we take the force acting on this surface, on the lower surface, we will consider this as F2 is equal to P2A. So we know pressure, how we have taken this formula? We know pressure is equal to force per unit cross section. Pressure is equal to force per unit cross section. Now see, the mass of the liquid inside this imaginary cylinder will also be acting some force in the downward direction apart from this force. So net downward directional force will be plus mg. So here the force acting downwards will be this one, and the force acting in the upward direction is this one. So here if the liquid is static and the net force on the cylinder is 0, so here we will consider as see mass is equal to volume into density. okay, into gravity. So F1 is equal to P1A plus volume into density. Volume is area of cross section into height of this cylinder. What is this height of this cylinder? We take it as h, okay, ah into density of fluid, we will take it as rho into g, okay. So this is the force acting vertically downwards, and the force acting vertically upwards on this lower surface is F2 is equal to P2A. So if the net force, the liquid is in static position, the net force should be 0. The net force on the cylinder should be 0. That is equal to F2 minus F1 is equal to 0. So look at this, F2 minus F1 is equal to 0, because the net for the fluid is in a static position, so the net force acting on both sides will be 0. So here F2 is, what is F2? P2A minus F1 P1A plus AH rho z is equal to 0. If you take common factor A for this entire equation, then it becomes P2 minus P1 is equal to H rho z. Okay, so here, or we can consider it as P1 P2 minus P1 is equal to H rho z. See, the negative sign is for direction only, so the pressure difference direction. So the net pressure between the 2 points in a static fluid, because of the height difference. See, this pressure is created because of the height difference between these 2 points. This is the height, right? So this pressure between these 2 points inside a static liquid will be applicable only there is a point of gravity. If we consider gravity only, then there will be net pressure difference between the 2 points. If there is no gravity, that means in absence of gravity, so P2 minus P1 becomes 0. P2 minus P1 becomes 0, right? In absence of gravity, P2 minus P1 becomes 0. Why? Because here G becomes gravity. So if there has to be any pressure difference between 2 points vertically placed vertically one above the other, and having a height difference between these 2 points, then the pressure difference will be H rho g, and in absence of gravity there will not be any pressure difference. Okay. So here if we take another case, suppose if we take this point P exactly on the surface of the fluid. So if we take this point P exactly on the surface of the fluid, so what is the pressure acting at that point? P1 is equal to P naught. P naught is atmospheric pressure. P naught is atmospheric pressure, and the point pressure acting on this point Q, P2, will become P naught plus H rho z. P2 is equal to P naught plus H rho z. This is when there is no gravity, and this is when the point is exactly on the surface of the fluid. So again, when the point P is on the surface of the fluid and the point Q is at the height h below the fluid, then the pressure acting at this point will be P2 is equal to P naught plus H rho g. So here we will see a small graph how the pressure will be varying with depth in a fluid. How the pressure will be varying with depth in a fluid. See, we just draw a graph between 2 points P. This is pressure, this is height inside the fluid. So this graph will be just like this. This is P naught. See, there will be already some atmospheric pressure acting on the surface of the fluid. So the pressure will be already P naught, and then the pressure will move upwards with increase in height from the surface of the fluid. This height will be the difference between the 2 points where we have calculated the pressure difference, right? So this is the pressure and height graph between these 2 points. Okay, so this is how we calculate the pressure difference between the 2 points in a fluid which is not moving, which is static. So in the next class we will see some more topics on fluid dynamics which are little bit useful for IP, NEET and JEE mains and advanced students. Okay.